Okay, we are going to go ahead and start. We may have a few more people still rolling in on Zoom. Let's see. So welcome to the data analysis in Excel workshop. We're with the Statistical Consulting Lab. I'm Taylor, and I'm in the Applied Data Science Master's Program. And
I'm Eden. I'm also in the Applied Data Science Master's Program.
And we're both senior statistical consultants with the lab. So some more information on the Statistical Consulting Lab. We're located here, and if you're in person, you're very close to our office already. We're in the office suite over there in 308 M. And then there are hours. We try to stay open every day, but it depends on the semester because next semester we'll have new consultants. So it depends on their schedule and how free they are. So it may change. All right, so the agenda for today for the workshop. First, I should just say we have distributed a data set and a PowerPoint to everyone. And so this is kind of a hands-on workshop, but it's kind of hands-off. You can pull up the data set if you'd like to work with us while we're going through the presentation. So first, we're going to talk about some different data cleaning techniques. We'll talk about why it's important to clean your data. Then we'll talk about descriptive statistics, which give you an idea about your data, and then some visualization strategies as well in Excel. And then lastly, we'll talk about some common Excel functions that are used for statistical analysis, and then some that are a little more advanced with a tool pack that we'll install. Okay, so let's get started. Okay, so thinking about Excel and data or in statistical analysis, a lot of the times when people perform statistical analysis, they first think of something like using R or Python or SPSS. And if you've used any of those, you know that they can be a little bit difficult to understand, especially at first. There's a bit of a learning curve. So that's why we would look to Excel, because most people are familiar with Excel already and don't know about all the things you can do with statistical analysis in Excel. So like I said, Excel is just easy to work with. It has a simple interface that you can use. It allows you to work with data in multiple formats. So the most common one being CSV. And it also has some basic functions already that can help you with your statistical analysis. And it can even go as far as doing like a type of regression analysis as well. And these are things that we'll be talking about in our workshop today. So this may be a review for a lot of people, but when we created the workshop, we kind of wanted to meet in the middle in terms of how experienced people were with Excel. So just navigating the interface. If you're not familiar, you can see on the screenshot here, this will get you to basically the formulas, and then you'll go to more functions in statistical. And these will be some of the basic statistical formulas that you can use for your statistical analysis. So like chi-square test if you're working with qualitative data, but the average and then the standard deviation as well. And so, like I said, these functions are a really good starting point for your statistical analysis, but they're a little bit limited. So that brings us to our next thing, which is the data analysis tool pack. This is actually a tool pack that it's not already installed in Excel when you first open it up. So you do have to install it. It's an additional thing. These are the steps for installing the tool pack. So essentially you just go to File, Options, Add-ins, and then Analysis Tool Pack, and that will allow you to install it. And so then once you install it, you should be able to go to the Data tab, Analysis, and there should be this here. If it's not there, then I recommend, if you did install it, restarting the program and then going back into Excel. And it should be there after that. So this is something that we'll be working with throughout the workshop. This tool packet offers more advanced statistical tools. And if at any point you have a question about something that we're talking about on the slide, feel free and I can stop and try to help you. Because I know like some of this kind of builds upon itself, so I don't want to skip over anything if someone is still stuck on something.
We'll also have time for questions at the end.
So your data set that you'll be working with, sometimes when you have a data set, it's from data that you've collected yourself. And that's great. It's not as common though, because most of the time you'll externally source your data sets from Kaggle or data.gov. There are plenty of different places to find good data sets, depending on what type of statistical analysis you'd like to perform. People commonly source their data sets that they're going to be working with because it's a lot cheaper and it's takes way less effort to just source a data set. And why would you reinvent the wheel if somebody's already collected the data? So for this workshop, we're going to be using a data set. It's the housing prices data set. We actually sourced it from Kaggle. And so if you guys would go ahead and if you're trying to follow along, go ahead and open up that data set. With this one, the dependent variable is price, and then we've got some different features that would describe or affect price, such as the number of bedrooms, the square footage of a house, and we'll look at those relationships a little more in depth. So let's start with cleaning our data. Why should we clean our data? Because data is often messy. It's probably not going to be as messy if you've collected it yourself, but you can still make mistakes. So especially if you've sourced your data set, you always have to clean your data because, I would say the most common thing that you'll see in data sets that you've sourced is missing values. You have to take care of your missing values in your data set before you can move forward with your statistical analysis. You might have duplicates in the data set. So this would be even if you collected your data yourself. Let's say that you collected a data point and then you took a break, got distracted, maybe took a phone call, and then you went back to your data collection and you forgot. And so then you collected that data point again. So you can't have that in your data set when you're performing statistical analysis. And then it often has typos and inconsistencies. So like sometimes people will accidentally type in units, or maybe they do it on purpose, or they'll put like a $ where it should just be numerical data. We'll get into more of that with the housing data set and see if there are any inconsistencies in it. So in the long run, data cleaning really just saves time and it ensures accuracy in your analysis. So when you're performing a statistical analysis, you want to be able to say that your results, you want to be able to be confident in your results. But if you're not cleaning your data, how can you be confident in your results? Okay, so the housing data set, we added some things on purpose just for the purpose of this, this workshop. So the housing data set has one column that we're not interested in that we'll be taking care of. It has some duplicate rows. It also has some missing values that will need to be handled. And it has some inconsistent data in columns A and columns B. So filtering your data. Externally sourced data sets often include variables that aren't of interest to the study. So for the housing data set, there's a column that's called pref area. And for the purposes of this workshop, we're not interested in looking at that column. So you can just go ahead and delete it. And that's often the case with a lot of these data sets that you source from online, where people have been looking at other things that may just not be of interest to your study. And so it's perfectly fine if you just don't look at them or consider them and delete them from the data set. But anytime you're deleting anything from a data set, you should be cautious. Then yeah. So duplicates and missing data, it's easy to find duplicated rows within data sets. And then with duplicates, always they have to be removed. Unless, well, I guess it would depend on your variables, but like 98% of the time you need to remove duplicates. Missing data has to be properly addressed as well. There are many different ways to address missing data. Usually people just, if they don't have a lot of experience with statistical analysis, the first thing they want to do is just delete the rows with missing data. And that can work in some cases, but often not. Like I said, you really should be cautious with deleting any data. So something that I would do if I were looking at missing data, I would look at it per column. How much missing data do you have? So you'd look at the instances where you have missing data in the column, and then divide it by all of the instances in the column. So that would, and you can multiply it by 100, and that would give you the percentage of missing data in a column. If you have a column that has like 30 or 40% missing data, you might want to consider looking at another data set. To me, that's just kind of a red flag that the data won't be appropriate to use. But not always. I mean, if you collected the data yourself and you have missing data for some reason, you could look at more data collection. If you source the data set in some way, but often it's just easier to find a different data set if you have a data set that's not reliable because of missing values. There are other things that you can do with missing values that are kind of outside of the scope of this workshop, such as imputation, if it's a numerical value, or if it's a categorical value, you could do it as well. But that's a little bit more advanced. So we won't address that this time. And if at any time there are any words or anything, or like anything I'm talking about that doesn't make any sense, please feel free to like ask like for more clarification, because we're both like in the world of statistical analysis heavily because of our program. So to this stuff is kind of easy, but to others it's like foreign, and that makes total sense because it can be hard to work with statistical analysis. So moving on to, I want to take a sip of water actually.
I have a question. I should have asked it sooner, but how do you get access to the data set if you didn't register?
Oh, I mean, I can send it to you.
Okay.
Yeah.
Missing data, like how do we, you said something about if you have multiple, you can like calculate missing data with the ones that are actually there based on percentage and all.
Yeah, okay, so like, let's say you have 3 columns, and when you look at missing data, usually I like to look at it per column. So I'll look at one column at a time, and I'll show you how to do it with the example. But you'll look at the instances in that column where there are missing
And like,
values.
are they different variables?
And the different variables, so you'll take it one column at a time. So you'll also consider that, but I guess it just depends. Does that like make sense?
Kind of.
Okay. And we'll go into like more detail in the example, and maybe
I
it'll,
think that would,
yeah.
yes, thank you.
Any more questions? Okay, we'll just move forward then. So removing duplicated rows, this is the process of how you would do that in Excel. And the great thing with Excel is that there are multiple ways to do one thing. So this is how I do it. You may find an easier way to do it, and if you do, then you should use that. Okay, so in terms of removing the duplicate rows, for the housing data set, what you would do is you would click in cell A1, and then if you're using a Windows computer, you can do Control-All or Control-A, and that will select all of your data. And then you would go to the data tab with all that selected. You would go to data tools here, and then you would press this. This is the remove duplicates. And then this will pop up here. It has like all the columns that you want to check for duplicate values. Just make sure that all of those columns are checked, because you want to check for in all of your columns. And then you would press OK, and it will select the rows that are duplicated. And then from there, you can do what you would like to do, but for the housing data set, we're just gonna delete all of those missing rows. So you would just, while those are selected, you would press delete on your keyboard. And let's see, so like there's another way that you can do it as far as filtering, but moving on to, yeah, this, okay. So that's the other way that you would do it. And then you would press delete. All right, so thinking about format consistency, what I mean with format consistency is, like for column A for price, you may have had two different people collect this data. And one person has entered it correctly, just the numerics, no commas, no leading dollar signs or anything like that. But the other person may have put leading dollar signs, and having those leading dollar signs are good when you're creating like visualizations. But when you're performing statistical analysis, you just want it to be numerical like this with no commas, no leading dollar signs or anything, just the raw number. So for column A, what you would do to get that, you would select the column and then you would go to home, number, and then you would make sure that it says general. And once you do that, it should convert all of those values to where they're in the same format. It will take care of the leading dollar signs that we added to the column A. And I want to make sure like everyone's on the same page. Are we good to move forward, or should I slow down, or? Okay, yes, we're good. And if you already know some of this, I apologize, but like I said, I wanted to meet somewhere in the middle with what everyone knows, so. Okay, so entry consistency, it's kind of the same as what we were talking about before with the leading dollar signs in column A. But just thinking about like sometimes when you have measured things, people want to add units of measurements at the end. And so you wouldn't want to keep those units of measurements in your data set like this. So here in the housing data set, you can see that we have 3,760 feet or square feet. So you'd want to remove the FT from the end. And then to do that, you would select the column. No, you would do Control F, replace, enter FT and find, and then leave the replace option empty. So here's just an example, the screenshot of how to do that. Yeah, I think it makes a little more sense like when you're actually doing it, but I'll move forward. And then I'll like pass it over to Eden.
We're gonna talk about some descriptive statistics. So this is where we've kind of gone over the basics, and we're gonna go a little bit deeper into some visualization and then some statistics. So we have some basic formulas that you can use in Excel. You can use the sum, average, count. The sum just adds up all the numbers together. So let's say we want to calculate the total amount spent on housing in the data set. So you would take the sum, you would go to the cleaned data, which is sheet number 2 of the Excel sheet. And then you would click on column A, which is our money. And that would give the sum. And you can do similar things with the average and the count. So average just calculates the mean or the average value between several numbers. Say we want to look at the size on average of a purchased house in the data set, you would go equals, average, go to your clean data, and then select column B, which should be the size. And then you can also do the count, show how many instances of a variable exist. So for example, we can look at the number of houses purchased in the data set. So you would enter the equation equals count clean data in column A, which is our price column. Okay, so we can also do summary statistics. We can use the data analysis tool pack that we showed you how to download earlier. And the tool pack includes a summary statistics tool. You can calculate these for the column of interest, so that's price in this case. So here is a method of how to do it. Some interfaces might be different, but this is for like the common interface. You would go to data analysis, descriptive statistics. Okay, input the range, which is your column A. And the reason we start at cell number 2 is because the first one is our label. We start at cell number 2 and then go all the way down to entry number 537, which is all the way at the bottom of the data set. And then you would check the summary statistics box, check OK. And it gives you this output here on the right. I figured most of us know what the mean is, it's the average. And then I put some definitions of what some of the other lesser known definitions might be. But median is the middle. So if you were to order all the numbers in order, median is the middle, mode is the most common, most frequent value. And then we have standard error, standard deviation, sample variance, kurtosis, skew, range, which is the difference between the maximum and the minimum, maximum, sum, and count. So you can look at what I put what standard error, standard deviation, sample variance, kurtosis, and skew are. So because those are a little bit less commonly used, I thought. All right, so we're going to talk about outliers. An outlier is a data point that significantly differs from the rest of the data. So you can see an outlier from descriptive statistics or from visualizing the data. So we have a box plot right here, and to be silly, I made an entry that was like millions of dollars of a house and had an outrageous number of bathrooms and bedrooms. No house normally does that. So we can see that's obviously an outlier. And here's the box plot, here's the obvious outlier. You can remove outliers and continue with the analysis, or you can leave the outliers in. Just be intentional about whichever one you decide to do. Sometimes you would want to leave the outliers. For example, medical data, you might want to leave outliers because it's giving important information. But sometimes outliers are just a mistake. This is probably a mistake because no house has 50 bathrooms, but you never know. So just be intentional about what you decide on whichever way. Okay, so we can also determine the interquartile range, and you can use the interquartile range to detect outliers. The values above or below the outlier limits are considered outliers. So here are the instructions on how you would determine the quartile and the lower outlier limit and the upper outlier limit. And you can see we can figure out the minimum, quartile 1, median, quartile 3, maximum, and then the interquartile range. And then you have the limits. And then you can see that, so this is the bathroom outliers. You can see that the upper limit maximum is 50. So that's that outlier of 50 bathrooms that we had seen earlier. Are there any questions about this slide? Okay. So we're going to be looking at how to visualize some data. We have different ways of visualizing data, but for qualitative data, we usually use bar plots or pie charts. So graphs of qualitative data typically show counts or percentages. So suppose we are interested in the percentage of houses purchased that include air conditioning. So you would have to first count up the number of houses that include air conditioning and that don't include air conditioning. And then you could make a pie chart based off of that. With these instructions here, you would insert charts 2D pie. And just to take a look at this pie chart, We can see it has a title, percentages of homes with air conditioning. And you can see that 32% of homes have air conditioning and 68% of homes do not have air conditioning, which is interesting. But a lot of times with just the data columns, you don't get to see that information, but with visualization, you get to see new insights about the data. So we have a quantitative data graph. So graphs including quantitative data, plot numerical data to reveal patterns within and between variables. Typically, we use histograms, line plots, and scatter plots. Suppose we want to determine how the house price changes with the amount of area or the size of the house. So in this case, you can remove the obvious outlier in price by filtering. And then you can do a scatter plot to show the possible association between the two variables. So you can see the area down here on the x-axis and the house price on the y-axis. And you can see a slight association as houses get bigger, they become more expensive. But it's so much more nicer when you have labels on the graph, which is what we'll talk about. You can customize your graph. So we have labels here. Area is in square feet, price is in US dollars, and then we have that line, that linear association. You can see the association between the two variables. So adding a title and labels to make a graph makes it easier for the graph for you guys to read, for professors to read, audience members. Just interpretability is a lot nicer. Especially like if you do your graph, you know, you have a break or you turn it in, it's just nice to label the graphs. So that's just an example of how we did that. So pivot charts, we don't have an example for this data set, but we thought that you guys could play around a little bit if you wanted to. There's instructions on how to do a pivot chart and how to do a pivot table. Pivot charts are dynamic visuals of data. You can easily visualize how filtering the data affects relationships between variables. So traditional graphs are static and tell one story, but pivot charts are a little bit more user-friendly. And it's just all about filtering data in a nice, convenient way. So you can go to column, insert, charts, pivot chart, okay. And that's one way to do a pivot chart. And then we also have pivot tables, which resemble pivot charts in their ease of filtering and usefulness. And you can quickly calculate totals, percentages with the filter data of your choice. And you can compare filtered calculations with those of the entire data set. So there's instructions on how to do a pivot table. And you guys are welcome to play around with that, or we can continue to follow along with the presentation, but that way you guys have, and if anybody doesn't have the slides or the Excel, we can send it out. Just send us a message and we can resend it if anybody didn't get the materials. You want to play around with the data. So we're going to talk about some functions for statistical analysis next. We have some complementary functions that are used in conjunction with statistical functions. So the first one we'll talk about is if. If is a logical function that compares a value to a condition and returns a result based on if it's true or false. So suppose we want to create a new column to classify houses as luxury if the price is greater than, let's say, $12 million. Otherwise, we'll classify it as standard. So we have, that's how you would do that. You would go equal if, select from A to, which A is your price column, and then you would select your threshold or put in your threshold is greater than, in this case, 12 million. And then put in luxury or standard, and it would give you an output. You can also use VLOOKUP, and VLOOKUP searches for a specific value within a table and retrieves a related piece of information from another column in the same row. Suppose we want to look up the number of bedrooms based on area size. So you would use the VLOOKUP function. And we have 8,000 would be the area. B2 to C537 is your area, is the cells that you're looking at. And then 2 is area of bedrooms, and then false just tells the function to give an exact value. And that's VLOOKUP. And this is updated from what we sent out earlier today. There might be a mistake on what we sent earlier, but this is the correct version. So if anybody wants that, we can resend. You can also use index and match, which is like VLOOKUP, but is more flexible and allows search based on both row and column. Suppose we want to find the price of a house based on a given number of bedrooms. So you would use these parameters right here. And just to explain a little bit more in depth of what's happening, the 0 argument looks for an exact match. And if there are multiple matches, then the function is going to return the first match. And so if you want an average of all of the matches, then you can use average if. I'm going to keep going, but if there are any questions, just stop me. So for statistical tests, we'll talk about t-tests. And t-tests are can be paired or 2-sample. It's a statistical test used to compare the means of 2 groups. A paired t-test is when you're comparing 2 measurements from the same individuals before and after something happened. And then a 2-sample t-test is when you're comparing the means of 2 separate groups. So we're going to show you an example of a paired t-test in this data. If you'll turn to or look at sheet 4 of the Excel, if you have it, I put in 2 columns. I put in a price before a hypothetical market shift and a price after the hypothetical market shift. And then the other value is the t-test function. So this is your t-test. You would select the A column, which is your price column, B column, which is the next price column. So there's before and after. And then the 2 specifies a 2-tailed t-test. The 1 specifies a paired t-test. So again, this is paired. And for interpretation, you take the p-value. If the p-value is less than 0.05, the difference is significant. If the p-value, excuse me, and opposite for if it's greater than 0.5. Okay. So the last big statistical test we'll go over is the ANOVA. The ANOVA is where you compare the means of 3 or more groups. So the t-test, compare two groups. ANOVA, compare 3 or more groups. You can do a 1-way or a 2-way ANOVA. And you would look for interpretation, you'd look at the F statistic or the p-value. The F statistic measures variance between groups relative to within groups. The p-value is what I mentioned earlier. If its p-value is less than 0.05, you would reject the null hypothesis. There is significant difference between groups. And if the p-value is greater than 0.05, then there is no significant difference, and you would fail to reject the null hypothesis. So we'll show you how to do that. And it should be in that Excel sheet, the last example, last sheet. So suppose for our null hypothesis, we want to say that the means of the price across bedrooms are equal. And for the alternate hypothesis, at least one group has a different mean. So this is where you would use that data analysis tool pack that we showed you earlier. And if you have any questions, we can go over that as well. But you would go to data analysis, select ANOVA single factor, because that's the version that we're going to use for this. Then you would input the range, group, choose how your data is grouped, and then check that we do have labels for this data, and then click an empty cell or select something empty for where you want to display the results. We're also going to be talking about regression for just briefly. There's linear regression, logistic regression, Poisson regression. So there's different ways to implement regression onto a data set. Linear regression predicts continuous outcomes. Logistic regression predicts binary outcomes, which is just two things, one or the other, true or false, yes or no. Poisson regression is used for count data, where the dependent variable follows a Poisson distribution, usually used in biology. So suppose we want to use multiple linear regression with our two independent variables as area and number of bedrooms. So you would use the function equals line st. You would select whatever your target variable would be, which is A. This is in the clean data set. So A is your price, and then you would select your independent variables, which are area and number of bedrooms. So that should encompass that. Then you would select true and true, and you would get a bunch of numbers for your output. We'll focus on what a few of these numbers mean. The first row is the regression coefficient, so it's how to write that equation of the linear regression. And the third row is the R-squared value, and an R-squared value close to 1 means that it's a good fit. So we can stop for questions now, or you can wait till the very end. But if you have any questions about the example data set or how to go through anything, or you can send us a message in the chat about, please send the updated PowerPoint, or we do plan on sending a recording of this workshop to everybody. So you don't have to worry about asking for that because we plan on doing that anyways. But if you want any other materials, or if you want to set up an appointment, I'll pause briefly for some questions, and otherwise we'll take more questions at the end.
Yeah, and if you all want to set up an appointment, we do Zoom appointments and then we do in person as well. But with the in person, we also just allow you to walk in during our operating hours. So it's just whatever's most convenient for you. Someone will be there during our operating hours.
Well, I'll keep going, but we'll also be hanging around for questions at the end. But we're nearing the end of our workshop here. So we just wanted to go over a couple of resources that our institution has. So for survey design and data collection, you would go to the Applied Social Research Lab. For literature searches, you would go to the library, but then for any statistical analysis questions, you would come to us. We are the Statistical Consulting Lab. And as Taylor mentioned, we do appointments virtually, in person, walk-in, scheduled appointments. We have an email that we're constantly monitoring. So feel free to reach out to us for any statistical analysis questions. As far as upcoming workshops, we want your feedback about what you would like to see in the future. And we'll have a form you can fill out at the very end that will tell us how we did and if you have any suggestions. We do have some ideas for upcoming workshops for the rest of this semester, but if there's something that you'd really like to see this semester or next semester, just let us know. It would have to be related to statistical analysis in some capacity because we are the Statistical Consulting Lab. But otherwise, this concludes our presentation. And if you'll hang around for 1 second, the next slide is just our form that you can fill out. But we have our information right here, email, phone number, during office hours, and then our website. And lastly, here's the QR code for the workshop satisfaction survey. And if you guys wouldn't mind just to fill that out, tell us how we did and what you'd like to see in the future. Otherwise, we'll be around for questions. If you're on Zoom, you can feel free to ask a question or just put it in the chat. And if you're in person, we'll be around for questions as well.
Hello, please, can you go over the box plot?
Yeah.
Okay.
Okay. So this is the box plot we want to go over right here.
Okay, I want to know like how to even get the box plot in the first place.
Okay. Yeah, let's pull it up and we'll walk you through it.
So the first thing that you'll want to do is you'll want to select the data that you're looking to use in the box plot. And then once you do that, you should be able to go on the upper ribbon to insert. Do you see that?
Yes, I see that.
Okay, and then you can go over to charts.
Okay. Okay.
Click through and see, eventually it will be here. So.
Okay. Insert.
What to insert?
Yeah. Okay, so it's not like in the main ones that it shows, but if you go to the charts, you can see to the right at the bottom, there's a little thing where you can click and it says
There's a little arrow to click.
recommended charts and then go to, it'll come up with the recommended charts, but you can tab over to all charts. And then you can see to the left, there is the box and whisker.
Okay, thank you.
What about this too? Like I trying to do like a box plot one, but they only accept if you have five column with numbers. So like if I have a 3 columns with numbers, like they don't allow me to do the box plots. Or do they?
You should be.
Because I try and
You
they're
try
like,
to do them individually.
no, I do like select them all, and then they say like you need to have 5 columns with no.
Really?
Yeah.
Let me come look at your.
Yeah.
I take it off, but
Oh, okay.
yeah.
Or you can come by and
Okay.
we'll look at it together if you
Okay, that
want.
would be nice. Yeah.
We have a question in the chat too. Yeah, someone wanted to see us actually making a box plot. I think I can do that on here, yeah. Please stop sharing for just a moment, and then I'll come back and show you how to do that. I have to get the data set for this computer. All right, so to do the box plot, let's say we want to look at a box plot of price to see if there are any outliers or see if we can notice anything about the distribution of the values. So we would select the column A for price, and then you would go to, it may look a little different depending on if you're on the web version or the desktop version. So let's see.
Oh, okay, there.
So if you're on the web version, it'll be like that, and it looks a little different on the desktop version, but it's kind of the same. Click on that. And then the reason that it looks like this is because of the outlier here. So let's remove the outlier actually. I think I'm just gonna open this up in desktop. I'm not used to using the web version. Okay, so once I remove that outlier, you can see here's the box plot. And if you're looking for other outliers, when you're looking at a box plot, usually this is like a first step in looking for outliers, but it's a good indicator if you have some data points that are outside of the whiskers here. But that's how you would make a box plot in Excel. Does that help a little bit?
We can go through those steps again if anybody missed that. Otherwise, we can, if anybody else has any questions, feel free to ask.
I do want to ask though, like the people that are here, and if you want to put it in the chat, do you think it would be easier if we did this workshop like showing Excel rather than a PowerPoint? Okay, that's what I thought. That's good feedback because we have to present this workshop somewhere else and we'll have to modify it, but
Were the screenshots helpful? Should we go like back and forth between the PowerPoint and the Excel, you think?
yeah, sometimes
Yeah, okay.
it's just hard to describe how to do things just with a PowerPoint. So we'll do that for next time. Okay, so we'll just continue recording. If someone else has a question, maybe it could help someone, the answer could help someone else. But we will stop recording at 4:30 when the workshop ends.
Thank you, yes.
Pretty much.
Well, for coming. Yeah, I think it's safe to just go ahead and stop the recording and end the meeting. I don't think anyone has any more questions. So I'll just do that. But thank you all for coming over Zoom and in person too, of course. Hopefully you can come to one of our next workshops too. And there should be some advertisements going out about it probably in the next couple of weeks or so. So just be looking out for those. Thank you.